Hello, my name is SYAHMI, and in this video, I'll be explaining two key engineering concepts, fail-safe and safe life design. These principles are incredibly important, especially in aerospace engineering, where safety is always a top priority. Today, I'll explain the differences between these two design approaches and show you real examples of how they are used in the aviation industry. Let's get started. Let's begin with fail-safe design. Fail-safe means that if one part of a system breaks, the system is designed to keep working safely for a while, allowing them to fix the problem without causing harm. This type of design assumes that parts will eventually fail at some point. Nothing lasts forever, right? But what's clever about fail-safe is that the system is built to keep working even after a failure, this for long enough to make things safe and allow repairs. Take the aircraft hydraulic system as an example. This system controls critical parts like the landing gear, brakes, and flaps. To make sure the plane can still land safely, engineers use multiple hydraulic reservoirs and redundant hydraulic circuits. What does that mean? Well, if one hydraulic system fails, for instance, if one reservoir runs out of fluids, there are still backup systems in place to take over. This redundancy is key in a fail-safe design. Even though one part of the system fails, the plane can keep flying safely until it can land and get the issue fixed. It is a smart way to ensure that one failure doesn't lead to a disaster. Now, let's move on to safe life design, which takes a different approach. Safe life means a part is designed to be replaced before it ever breaks. Engineers calculate how long the part can last safely, and it swaps out before it fails to prevent any risk. Instead of allowing parts to fail and then relying on backups, safe life focuses on preventing failure completely. A good example of this is the turbine blades in an aircraft engines. These blades face extreme conditions such as high temperatures, high speeds, and a lot of pressure. Over time, this condition causes the blades to wear down. Engineers calculate how long the blades can safely last. Usually in terms of flight hours or cycles, once the blades reach their predicted lifespan, they are replaced, even if they still look fine. This is done to make sure they don't fail unexpectedly during the flight. So, safe life design is all about preventing failure before it ever happens. It's a way of ensuring that critical parts are always replaced on time, avoiding any chance of them breaking down while in use. So, how do these two approaches compare? In fail-safe design, the hydraulic system, we expect failures to happen but design the system to keep operating safely until repairs can be made. Another example of this is having two engines on an aircraft. If one engine fails, the other can keep the plane flying long enough to land safely. On the other hand, with safe life design, like the turbine blades we discussed, we replace parts before they fail, based on how long we expect them to last. The landing gear is another example of the safe life. Since it undergoes intense stress every landing, it's replaced at a set interval to prevent sudden failure. Both approaches are important. Fail-safe is great for systems where backups are possible, like hydraulic system or multiple engines. Safe life works best for parts that are critical and can't afford to fail, like engine components and landing gears. Engineers choose between these strategies based on the specific needs and risk of the system. To wrap things up, fail-safe and safe life are two smart ways engineers keep systems safe. Fail-safe design is all about building in backup options. So, if something does go wrong, the system can keep running smoothly. On the flip side, safe life design is more about being proactive, replacing parts before they ever have a chance to fail, especially for parts that handle a lot of stresses. Both approaches are key, especially in areas like aviation, where safety isn't just important, it is essential. By choosing the right design for each part, engineers make sure this complex system stay reliable and ready. Thanks for watching. I hope this made the differences between fail-safe and safe life design a bit clearer.